Imagine a place where the laws of physics break down, a place of immense gravity where even light cannot escape. This is not science fiction but a very real phenomenon: black holes. These celestial objects are regions of space-time where gravity is so strong that nothing, not even light, can escape its pull once it crosses the event horizon. Black holes are often depicted as cosmic vacuum cleaners, sucking up everything in their path. However, this is a misconception. While their gravitational pull is immense, it obeys the laws of physics. Objects in orbit around a black hole behave just as they would around any other massive object. The true mystery of black holes lies within their event horizons, the point of no return. What happens beyond this point remains one of the biggest unsolved mysteries in modern science. Black holes are not random occurrences, they are the remnants of stars that have reached the end of their life cycle. Imagine a star, much more massive than our sun, burning through its nuclear fuel at a furious rate. As the star exhausts its fuel, the outward pressure from nuclear fusion weakens. This delicate balance between outward pressure and inward gravitational pull is broken. Gravity, now the dominant force, begins to compress the star's core with unimaginable force. This compression triggers a catastrophic collapse. The core implodes, and in a spectacular supernova explosion, the star's outer layers are blasted into space. What remains is a region of space-time so dense that not even light can escape its gravitational pull. A black hole is born. Stellar black holes can be a few times more massive than our sun, yet their event horizons may only span a few kilometers. Black holes, shrouded in mystery, have captivated the human imagination, often portrayed in popular culture as cosmic portals or monstrous devourers of worlds. While these depictions make for compelling science fiction, the reality of black holes, as revealed by science, is even more fascinating. One of the most pervasive myths is that black holes act like cosmic vacuum cleaners, sucking up everything in their vicinity. In reality, a black hole's gravitational pull, while immense, behaves according to the laws of physics. Objects caught in its gravitational influence would orbit the black hole, much like planets orbit a star. Only if an object crosses the event horizon, the point of no return, would it be inevitably drawn inward. Another common misconception is that black holes are portals to other dimensions or universes. While the extreme warping of space-time near a black hole makes such possibilities theoretically intriguing, there is currently no scientific evidence to support these claims. Black holes, despite their depiction as destructive forces, play a crucial role in the evolution of galaxies. Hollywood, with its penchant for spectacle and drama, has often turned to black holes as captivating plot devices. From classic movies like Disney's The Black Hole to the awe-inspiring visuals of Interstellar, black holes have been portrayed as both gateways to other dimensions and celestial threats to humanity. Interstellar, while visually stunning, takes creative liberties with the science of black holes. The film accurately depicts the time dilation effects near a massive gravitational object where time slows down relative to observers farther away. However, the notion of a five-dimensional tesseract residing within a black hole, while imaginative, remains purely speculative. Despite these fictional liberties, Hollywood's fascination with black holes reflects our own curiosity about these enigmatic objects. By bringing these cosmic wonders to the screen, even with dramatic embellishments, movies spark public imagination and inspire further exploration into the mysteries of the universe. The study of black holes is a journey into the unknown, a quest to understand the most extreme environments in the cosmos. Scientists, equipped with ever-advancing technology, are making groundbreaking discoveries that are unraveling the mysteries surrounding these celestial objects. The Event Horizon Telescope, a global network of telescopes, provided the first-ever image of a black hole's shadow in 2019, a monumental achievement in astrophysics. This groundbreaking image, capturing the supermassive black hole at the heart of the galaxy M87, confirmed decades of theoretical predictions and opened new avenues for studying these enigmatic objects. Future missions, such as NASA's Laser Interferometer Space Antenna, aim to detect gravitational waves, ripples in space-time, emanating from merging black holes. By studying these waves, scientists hope to gain insights into the dynamics of black hole collisions and the properties of gravity itself. The exploration of black holes has profound implications for our understanding of the universe. Black holes, once relegated to the realm of science fiction, have emerged as tangible cosmic entities, challenging our understanding of the universe and captivating our imagination. From their birth in the fiery death throes of massive stars, to their role as anchors in the grand cosmic ballet of galaxies, black holes continue to intrigue and mystify. The quest to unravel the secrets of black holes is a testament to the human spirit of exploration, our innate desire to comprehend the unknown. As we continue to probe the depths of space, armed with ever-evolving technology and insatiable curiosity, we can expect even more groundbreaking discoveries. The journey into the heart of a black hole is a journey into the very essence of existence itself,